Parallelogram or quadrilaterals. Remember at the very beginning of quadrilaterals, I said you can break them up into 3 categories. Parallelograms have 2 sets of parallel sides. Trapezoids have 1 set of parallel sides. And the general quadrilaterals have no sets of parallel sides. Okay? We are going to talk about one kind of general quadrilateral today, a kite, but they don't have any parallel sides. All right? So the first thing we're going to talk about today is trapezoids. And trapezoids, the one that has the most characteristics is an isosceles trapezoid. So think of what an isosceles triangle is. What's an isosceles triangle? What does it have? 2 equal sides. An isosceles trapezoid does the same thing. It has 2 equal sides. And the sides that are equal are the legs. Okay? The 2 non-parallel sides. We call the parallel sides the bases and the non-parallel sides the legs. So in a isosceles trapezoid, the legs are equal. Okay? All right, the characteristics of an isosceles trapezoid are that the base angles are congruent, just like an isosceles triangle. Remember, an isosceles triangle, if the sides are equal, the 2 base angles are equal. Same thing with an isosceles trapezoid. If the sides are equal, the legs are equal, then the base angles are equal. And the thing about an isosceles trapezoid is you can turn an isosceles trapezoid upside down. So not only could these be base angles, but so could these, right? If you flipped it upside down, because the trapezoid has 2 flat sides. So, all right, and if the whole thing, how many degrees are inside a quadrilateral? 360. So if these 2 are equal to those 2, don't these 2 have to be 180? And those 2 have to be 180? Or, if that didn't make sense to you, these are parallel lines, right? So that makes this a transversal. So these are same side interior angles, also supplementary, right? So the 2 sets of angles are supplementary, base angles are congruent, and the last thing is diagonals are congruent. Okay, so if you draw diagonals through the isosceles trapezoid, they are also congruent. None of this got erased. All right, so, I'm sorry. All right, so if that's 49, what's that? 49, because it's equal. Can I figure out this one? Right, 180 minus 49, which is 131. Good. Right, and that one would be 131. $63, right? Because these 2 would equal 180, and these 2 would be equal. Okay? All right, let me just show you quickly how to solve this one, because you're going to get some equations with squared terms. Okay. What do we know about these 2 angles? Good. They're equal to each other. So I would set 2x plus 19 equal to 4x squared minus 13. So I would treat it just like any other equation. I'm going to get the variables on one side, the constants on the other. So I'm going to move the 2x squared over here. I'm going to add the 13 over here. And that gives me 32 equals 2x squared. Just like the x doesn't change if you subtract 4x minus 2x, it still stays x. Same thing with squared. 4x squared minus 2x squared is 2x squared. All right? Then I divide by 2, and I get 16 equals x squared, because the 2's cancel. And then how do you undo a square? Square root. Good. So I take the square root of both sides, and that's x equals 4. Okay, does that look familiar? Okay, good. All right, so that is isosceles trapezoids. Now, all trapezoids, not just isosceles, but all of them, have a mid-segment, just like a triangle does. Okay, it is found by finding the midpoint of that leg and the midpoint of that leg and then connecting them, just like a triangle. Okay, so the mid-segment is where the midpoints connect. All right, and remember on a triangle, you took half of the base? Well, the thing with a trapezoid is there's two bases. So which one do you take half of? Yeah, you don't have to decide because that would be unfair and one of the bases would feel bad. So instead, you're going to add them together and then take half. So basically, you're taking the average. Okay? So like 13.5 plus 8 is 21.5. Divide that by 2, and that gives you 10.75. So the length of this mid-segment is 10.75. Okay? So just like a triangle, it's parallel to the bases, it's the midpoints connected, but instead of just taking one side and dividing by 2, you're going to add them together and divide by 2. Okay? Now this one's a little different because they didn't give us one of the bases. They gave us the length of the mid-segment, right? But they didn't give us both bases. So I'm going to call this base x, okay? And then I'm going to use the formula, the same formula I did over here. I'm going to do x plus 38 divided by 2 is 31. So this time, instead of trying to figure out the answer, I'm trying to figure out one of the pieces of the problem. All right, so to solve this, I need the fraction bar works like a parentheses, so I got to get rid of it. And the way I get rid of it is I multiply both sides by 2. So those cancel, and I have left x plus 38. And then 31 times 2 is 62. Okay, then I subtract 38. And that gives me x is 24. All right, so the length of this base is 24. All right, can you figure out what the length of that base is? Okay, so you add them together, even if one of them's x, divide by 2, and set it equal to the mid-segment. All right, so that's everything you need to know about trapezoids. All right, let's move on to kites. So the overriding thing you need to remember about kites is that through the center of a kite is a line of reflection, okay? So if you draw that line through a kite, it is a perfect line of symmetry, okay? Which means then that like this side is equal to that side, this side is equal to that side, this angle is equal to that angle, this angle is equal to that angle, this angle is equal to that angle, right? Everything is a mirror image. That's the key. If you can remember that that middle line is a line of symmetry or a line of reflection, that'll help you remember all the characteristics of a kite, except one more, and that is the diagonals are perpendicular. Yeah. Okay? And if it's reflective, doesn't that mean this piece is equal to that piece as well? Right? But do these two equal? Not necessarily. It's not a reflected piece. Okay? And that's what all this says, is that this angle equals that angle, these sides are equal, these are equal. That's what all that says. Okay? All right. All right, so if I want to solve this kite, okay, it tells me, the listing here says that FEJ is 25. So FEJ, right here, is 25. And FGJ is 57. Okay, which one is the line of symmetry, or the reflection line? This one or this one? Good, this one. So everything from this side is equal to everything on that side. So if this is 57, what's this one? Right. 25, 25, right? What kind of angle is this? 90, good. Okay. And then if I want to find this angle, anybody have an idea how I'd find it? I do, yeah, these two, if I had this plus this plus this, would that give me one triangle? So that'd be 180. So 57 plus 25 plus x is 180. So that gives me 82 plus x is 180. Subtract 82 and I get x is 98. So this one's 98. What's that one? 98. Okay. The other thing they like to do with kites, okay, is because these are right angles, these are what? What kind of triangles? Right triangles. So if I told you that this side was 3 and this side was 4, could you find this side? Using what? Pythagorean theorem. Right. So they like to use Pythagorean theorem with kites for some reason. That's a problem you see all the time, like on the OGT and the ACT. So the legs are A and B, so it's A squared plus B squared equals C squared. Okay? So that's 9 plus 16 equals C squared. 25 equals C squared. So what's C? 5, because you take the square root of both sides. Does that make sense? So I think a couple of the problems on the homework, you have to use Pythagorean theorem. Okay? All right.